So hello everyone. Today we'll talk about the Unit 3, electricity and electromagnetism. We'll talk about static electricity, conductors. We start with conductor. Conductors are materials which allow current to flow through them. Okay, you got like the metals, as you can see here. The metals are positive ions embedded in a sea of electrons. As you can see, a lot of electrons can carry the current from one place to another. And also the sodium chloride solution here. The sodium is a positive ion, so it will go to the cathode, and here it's negative ion, so it will go to the anode. So as you can see here, the current will be taking place normally as if they are one unit. So here we are talking about conductors, example metals and sodium chloride solutions. Let's see what's inside them. So as you can see here you can see the positive ions, and you can see negative ions are running all over the place to carry the current from one place to another. Once it's connected to a battery, the battery will make things to go in only one direction. As you can see, to take the flow of electrons will be in one direction, taking the current. So we shall continue with the electric field. What's electric field? It's a region where charged particles experience a force. So for example, if you are having an electric field like this, and always the electric field is coming from a positively charged to a negatively charged plate or substance. For example, here a positive plate was down and the negative plate is up, so the direction of the electric field is from down to up. So what will happen is that, what if I added here a positively charged particle? If I add a positively charged particle, no way the positive charge will be attracted to the positively charged plate. So what will happen is that this positively charged will go upward. So there will be a force due to this electric field that will push this positively charged toward the negative plate. The same will goes for the negatively charged. Negatively charged, it will experience two forces, one from the electric field and another one force of attraction between the negative and the positive charge. So as well here, this negative charge will experience a force. That's for the electric field. So as you can see also, the positive charge, always the electric field is coming out of the positive charge, like here it's coming out of the plate. And negatively charged, it's always coming inside the negatively charged. That's one point. So the arrows shows the direction of the field, which is from positive to the negative. The spacing between the lines demonstrates the strength. So whenever the strength, it became stronger, the electric field is stronger, so it means the lines will be so close to each other. That's for this part. Then we talk about the insulators. What's the insulators? Those are materials that do not allow current to flow through them. Example, wood, plastic, nylon, rubber, glass. And now you can see the insulator. This is how the insulator will look like. As you can see here, there is no room so that the electrons could flow between the positive parts. And here you can see some of the examples of the conductors and insulators. Okay, so now we'll continue to the charging insulation by frictions. What will happen when you have two insulators and then you apply friction between them? Let's see in the next demonstration. Here, as you can see, all these items were neutral. Why neutral? Because the positive is equal to the negative. The positive is equal to the negative. So for example, if it has 3 positive, it will have on the other side 3 negative. So they cancel each other. So I can say that they are neutral. Okay. Now, what will happen if we apply friction between those two insulators? What will happen is that friction between these objects, electrons will flow from one of them to the other. So now here, this cap, it was neutral, which means the positive was equal to the negative. And then at once it lost the most of its electrons. Lost where? To the other side. So what will happen to the positive on this hat? Positive will have a more population, or it will be much greater than the negative. So it means that now the cap will be positively charged. I can say that. And what about this bag? I could say easily that it will become negatively charged. This will stay temporarily like this until this will regain they will regain the neutrality once more. So returning back here, we shall have, once we have this wool duster, we apply friction between this wool duster and this ruler. What will happen? This wool duster will transfer the electron, or the electron will transfer from the wool duster to the ruler. So what will happen is that this ruler will contain a lot or much more negative charges than the positive charges. So I could say that now the ruler will become negatively charged and the wool duster will become positively charged. So as we said, only the electron will transfer, while the positive will not transfer anywhere outside the substance. So the positive can only travel inside the substance. For example, this positive could come here or go there, but it cannot go to the outside like the electrons. So the only thing that transfers from one place to another is the electron. Okay. Then, as you can see, gain of electron, whether you gain electron or lose electron. If you gain electrons, so you'll be negatively charged like the ruler. If you lose electrons, so you'll be positively charged. On reapproaching the electron, transfer back, as we said, this is temporary action. Then they will regain their neutrality again. We have some application that we could just mention if you were asked about the application. And here, in these applications, we are using the idea that of having a positively charged, for example, we apply a positive charges on this number 3 on the paper, and then the color will be negatively charged, so they will attract each other to form number 3. Like the car paint, if you want to paint some parts of the body, you make those parts negatively charged, and then you spray the color which will be positively charged, so it will be attracted only to the parts that you need to paint. Pesticide, if you need to apply pesticide to parts of the plant, and these parts are so they apply a positive charge on the parts, and then you apply the pesticide, and then they will attract each other on only the specific part that you need to add the pesticide on. Last thing, neutral conductors. When you approach a positive rod, they will attract. When you approach a negative rod, they will attract as well. How? As we said before, for example, here, this is a neutral place. So what will happen? This is a neutral, for example, rod. What if I applied a small rod? This small rod was positively charged. A positive charge. So what will happen? Let's apply this rod from the other side. What will happen? It will be attracted to the negative that is on the same side. So what if I removed this, and then I applied another rod which will be negatively charged. What will happen? Only what will occur is that there will be a redistribution of charge inside this substance. For example, here the positive charge will be near to the rod and the negative charge will be far away from the rod. So both will attract each other, whether it's a positively charged rod or a negatively charged rod. Both will be attracted if they came or they approach to a neutral conductor. Thank you so much.